Okay, so that's 10:30, just started up. Okay, so back in the workshop to have a look at these seals to see how they've handled things. The first thing I notice is this dust here, this white dust. Now this is the bits of the PTFE seal which have formed the bits. The seal is actually, it's failed to some extent towards the end of the day, is leaking fairly badly. Surprisingly, it didn't seem to be affecting the power a great deal. The output power reading of the Stirling engine was probably the highest I've ever seen it actually. It managed to light the whole light bank up that I had. And even then it really wasn't quite enough to keep the engine at a reasonable speed. Alright, so I've just undone all the bolts, disconnected this linkage, take this ring off. Remove seal. So in total this seal's done about 6 hours roughly. There you go, so on that side it's still intact, but this side has worn away. On this seal design, actually, I cut down the or increase the internal diameter of it, so there's less seal pressing against the cylinder. I'm wondering if doing so, I've actually caused a wedging effect, which has worn the seal away. Alright, so this is the sort of thing that's I think it's been happening with the seals made out of 1.5mm PTFE. Because I've reduced the internal diameter of the donut that I've made the seal out of, like the donut shape, they're already coming in like this. So there's a chance of them wedging when the piston's going up. The seal's being wedged upwards, which is wearing it away quickly. On the other side of the old seals that are made out of PTFE, which seem to be causing a lot of friction, they had a smaller inside diameter, so there was more this sort of shape going on than this shape. But the only problem was, because they were 2mm PTFE, they're actually causing quite a lot of friction on the piston. I've been looking at air cylinders and the pistons on those, and they have more this sort of shape to the seal. I think it's so when the piston's moving backward and forwards, there's less tendency for it to wedge in there like that. Right, so what I propose for the next attempt on seals is so that'd be the piston, or one side of the piston. That'll be the tube that it fits in, and that'll be our bolts, our ring of bolts on the top. The pen's running out. So that'll be our bolts there. So I'm going to get the 1.5 PTFE, which will exert less pressure on the piston, causing friction, and then actually force it in a more of a 90-degree kind of shape like that around the corner. So the hope is we won't get the wedging effect that we saw in the other one, but also the 1.5 will actually exert less pressure on the piston. So I'll try and fit that in a minute, see if that will fit. So there you go, I've made a new set of PTFE lip seals, or donuts. This is 1.5mm material. The inside diameter I've reduced to 120 from 128. So the hope is, because there's a space there, the space around the outside of the piston is about 3mm. The hope is that I can force these down over so the lip is pointing downwards like that, so it'll be bent down like that, and I can actually get that lip to go down the gap there, like so. So for this I'm going to get the hot air going in a minute and heat it up. Alright, so I managed to have forced it down like so the lip's pointing downwards. I'm just going to heat it up a little bit more with a hot air gun. Right, so I put the metal ring on, now I'm going to tap it down. Right, so I've put a few nuts on now, so I'm just going to heat it up once again. Now the hope is I'm going to be able to tighten the nuts up, four nuts, as well as moving the piston down, which will hopefully force the PTFE down the gap and create a nice square edge of the seal. Right, so I'm going to turn the engine over, move the piston down just a tad, that should do it, and continue tightening. So there you go, all tightened down. And if you look at the seal a bit closer, you can see there's a definite like 90-degree turn now on the seal rather than a gentle radius. Of course, it really depends whether we can turn the engine over or not. I'll try and reach across and get the flywheel. So it turns over, but will it work? That's the question. Initially, there seems to be a bit of resistance. I'll just pop the bolt out of the piston there. Get the locker out of the way. It's not the problem is because there's pressure in the engine. It's not really. I mean, I can move it. Of course, it might actually free up a bit when I start to use it. So there you go. I mean, it's holding air. That's a certain, as you can see, and it is lowering under its own accord, so it's not that tight. I'll go ahead now and do the same to the other side. So I've got the two connecting rods disconnected on the hot side because I'm working on the seals. So it's given me the opportunity to turn the engine over just so I can have a look at the other side. Now these PTFE seals are the 2mm ones. So I cut out a 120mm hole in the middle of those discs, and the diameter of that is 140mm. Now there is a little bit of resistance on these really, and there's noise as well. You can hear the dragging, so that's just something to note really. There is resistance here. So there we go, all back together. It's a bit tight at the moment. I mean, it's not too tight. I think the best thing we can do is give it a go at some point. Maybe a bit of heat and a bit of movement will let us know whether this is a viable option for sealing or not.